Hey guys, today we are here again to make another confusing topic easier for you. So like, share and subscribe if you haven't already so that you don't miss any further videos coming from me. So here's the question: which of the following graph shows left ventricular loop pressure volume loop? Which of the following corresponds to the V wave of the JVP? So to solve this question, first we'll have to get clear with the cardiac cycle. So it starts with the atrial systole, where the atria pumps blood into the ventricle. Then the ventricle, the opening of mitral, then the mitral valve closure takes place after the atrial systole has taken place. Then the isovolumetric contraction, where all the four valves, that is the mitral and tricuspid, aortic and pulmonary, all valves are closed during the isovolumetric contraction. Then is the ventricular ejection, then the ventricular relaxation, and then the ventricular filling takes place. Okay, so this is the cardiac cycle. Here we can see that the heart is receiving the the left atrium receives the blood from the four pulmonary veins, and the blood is going from the aorta, from the left ventricle to the aorta, okay, through the aortic valve opening. So what happens is, this is by default a rule that when the only one of the four valves could be open at any particular time. These are the atrioventricular valves, and imagine these gates to be the four valves that we have. So this is the left atrium, this is the left ventricle, this is the right atrium, and this is the right ventricle. So what happens is, the moment when the mitral valve is open or the tricuspid valve is open, that is the atrioventricular valves are open, the semilunar valves, that is the aortic and the pulmonary valves, would be closed. So it never happens physiologically that all the four valves are open simultaneously. Then during the isovolumetric contraction phase, what happens is that all these four valves are closed. All of these four valves are closed during the isovolumetric contraction phase. Okay, so the ventricle is neither receptive nor nor ejecting its blood into the aorta. So this is the isovolumetric contraction phase, which corresponds to the C wave in the JVP. You can remember it as the cusp of the tricuspid valve bulging into the right atrium. So let's see the cardiac cycle here. So it starts with the systole starts with the isovolumetric contraction. Then the ventricular contraction, ventricular ejection takes place. So systole is, when we talk about systole, it's by default the ventricular systole, and systole happens when the ventricle ejects its blood from the left ventricle to the aorta. And then after that, the isovolumetric relaxation happens, that is the ventricular diastole. Ventricular diastole is when the ventricle receives the blood from the atrium. Then the ventricular filling takes place, and the last part of the ventricular diastole is the atrial systole. So when the ventricular diastole takes place, it means that the ventricle is getting filled with the blood from the atrium. And what happens is, the last wala jo blood bachta hai, the remaining blood that was not ejected into the ventricle, the atria contracts and gives force and pressure so that the remaining amount of the blood, that is the remaining volume, is ejected to the ventricle. Okay, so this is the cardiac cycle basically. So let's see the JVP first of all. So in JVP we have these ACXVY, where we have three positive waves, that is A, C and V, and X and Y descent are the negative waves. So it is ACXVY. So A is for atrial contraction, A is for atrial contraction, C is for isovolumetric contraction. So we can remember it as cusp, C for contraction, C for cusp of tricuspid valve bulging into the right atrium. Then S is for atrial relaxation. X is for atrial relaxation. Then V is for venous filling of the right atrium. V is for venous filling of the right atrium. And Y is for the ventricular emptying. Okay, so Y is for the ventricular emptying and V is for the venous filling. So what happens is, if we see the PV loop, this portion of the loop is the systolic phase. Okay, from B to C to D is the systolic phase, and from D to A to B is the diastolic phase. So what happens is, this is here on the x-axis, you can see that this is the volume is there on the x-axis. So this, from B to C, the volume is constant. So the systole starts from the isovolumetric contraction when all the 4 valves are closed. Then from D to C, if we go from D to C, we can see that the volume is decreasing from 90 to somewhere around 20 to 40. So this is the ventricular ejection. Now what happens is, why does the volume decrease from C to D is that when the ventricular systole takes place, the ventricle ejects its blood into the aorta. So when the ventricle is ejecting its blood to the aorta, the volume of blood in the ventricle would decrease. So this is C to D is showing your ventricular ejection. Then from D to A, it's isovolumetric relaxation. So D to A is isovolumetric relaxation, and A to B is ventricular filling, because from A to B we can see that the volume is increasing. So this is ventricular filling. Now what happens is, your systole starts with isovolumetric contraction, and the diastole starts with isovolumetric relaxation. Diastole is isovolumetric relaxation where the ventricle is receiving blood. Okay, so ventricle is receiving blood, and to receive blood, the aortic valve is closed. The aortic valve is closed, and during the systole, the mitral valve is open. No, the aortic valve is open, sorry. The aortic valve is open, so that the ventricle can eject its blood out into the aorta. So, okay, we can use the analogy of these 4 gates here. So, this is your mitral valve, this is your aortic valve, this is your tricuspid, and this is the pulmonary valve. So, what happens is, during the ventricular contraction, that is the systolic phase, this valve has to be open. So for this valve to be open, the mitral valve would be closed always. So the mitral valve would be closed, then this valve can be open. So as I told you, normally physiologically only one of the 2 valves could be open. If semilunar valve is open, if your semilunar, that is the aortic valve, is open, then the mitral valve has to be closed. That is the AV valve, that is the atrioventricular valve would be closed. Okay. Now what happens if we correlate it with medicine? What happens is, if this mitral valve doesn't closes, if this mitral valve is open during the systolic phase, then it leads to mitral regurgitation. So the murmur of the mitral regurgitation is pansystolic murmur. So the name pansystolic murmur comes from here itself, that it happens during the systole. Okay, if the mitral valve is not able to close, so this is the pathology. Normally, physiologically, this never happens. If the aortic valve is open, the mitral valve would always be closed. Now, what happens during diastole? This is the systolic phase. Now, what happens during diastole? If we take the analogy of these 4 gates, during the diastole, the ventricle receives blood. Okay, so if the ventricle is receiving blood, it is the ventricular diastole. So the ventricle is receiving blood. So for the ventricle to receive blood, the mitral valve has to be open. So here your mitral valve would be open and your aortic valve would be closed. Since only one of these two valves could be open at a time, they do not open simultaneously. Okay, they are never open simultaneously. Now what happens if we take the same example and draw 4 gates out of these valves? So we can see that all 4 valves are closed simultaneously. They can never be opened simultaneously, but all these 4 valves can be closed simultaneously. Now when all these 4 valves are closed simultaneously at the same time, this is the isovolumetric contraction phase. During isovolumetric contraction, what happens is the ventricle is neither receptive nor giving out. Neither it is receiving nor it is ejecting the blood into the aorta. Okay, this is the isovolumetric contraction. After this corresponds to the C wave in the JVP. After this, the ventricular ejection takes place when the aortic valve opens. Okay, so this is what I used to try to describe you here about the cardiac cycle. So let's see it again. So it starts with the isovolumetric contraction, then the ventricular ejection, then ventricular relaxation, that is the ventricular diastole. Now what happens is the diastole में क्या हुआ ventricle के, that the ventricular filling takes place. For the ventricular filling to take place, it is called as the ventricular diastole, when the ventricle is getting filled from the blood from the atrium. Okay, so what happens is after that जो थोड़ा सा बचा हुआ blood होता है, the atria has to exert more force. The atria exerts extra force and contracts so that the left out blood is also ejected into the ventricle. So that is called as atrial systole. Okay, when atria is contracting, it would be called as atrial systole, and when ventricle is contracting, by default we take it as systole. So what happens is the ventricular diastole end part is the atrial systole. It ends with the ventricular diastole ends with the atrial systole. So the ventricular diastole is ending with the atrial systole. We can see here in this cycle also that the ventricular filling is taking place, which is the ventricular diastole, and it's ending with the atrial systole or atrial contraction, so that the left amount of blood is also ejected into the ventricle further. So this is the cardiac cycle. Then we have seen the JVP. Okay, so this is it. Then coming to the PV loop. Okay, so if we see the PV loop, what happens is from point A our systole starts. Okay, so this is the point A from where the systole starts. So half of this is your systole and half of this curve is your diastole. Okay, so moving further ahead in this, it starts from point A. So point A is where your isovolumetric contraction starts. Then this is your ventricular ejection. So here we can see that on the x-axis the volume is constant, so this is the isovolumetric contraction. Then during the systolic ejection, the volume is decreasing from point B to point C. Then from point C to point D is the isovolumetric relaxation, and here the ventricular filling takes place. So we can see from point D to A the volume in the ventricle is increasing. Okay, so this is the concept, and the width of the graph gives us the stroke volume. Stroke volume is end diastolic volume minus end systolic volume. This is also a question very favorite in INICET, so this is what we get here. So this was a concept. Now moving on to the mnemonic, we can also crack this question, the same question, with the mnemonic, that is Coco Ma'am. Okay, so here we have a mnemonic, Coco Ma'am. So Coco and Ma'am. So CMOACA and OM. That is the closure of the mitral valve. With the closure, so V wave in the JVP corresponds to the venous filling of the atrium. So it corresponds to the venous filling of the atrium. So when would the atrium get filled? The atrium would get filled when the aortic valve opens, so that the aortic valve ejects its blood into the aorta, which further gives the venous filling to the atrium. So for that, the aortic valve has to be open. So point C to D is where the V wave correspond. Okay, so this was our question. This is the question that we had to discuss here, that this is the answer here is C to D, that the ventricular ejection is taking place, which is further leading to the venous filling of the atrium, okay, which is corresponding to the V wave in the JVP. But also if we would see it with the mnemonic, then the mnemonic, as I told you, is COCO MAM. So it's COCO MAM, that is the mitral valve closure, opening of the aortic valve, closure of the aortic valve, and the opening of the mitral valve. So from point C to D, the venous filling of the atrium would take place, since the aortic valve is open here, which is the ejecting the blood from the ventricle to the aorta, and which would further lead to the venous filling of the atrium. So this is the question here. Okay, so let's see the Wigglers diagram now. Let's further simplify this complicated topic. So in the Wigglers diagram, we can see that this is the volume loop and this is the pressure graph. Okay, so what happens is, it's here also we can use this mnemonic COCO MAM. So this is the graph. This portion of the graph has been given here. Okay, it has further been simplified by giving here. So this is here also we have used the mnemonic COCO MAM. So this is COCO MAM, that is it starts with the closure of the mitral valve, then the aortic valve opens, then the aortic valve closes, then the mitral valve opens. Okay, so here what happens is, this graph is for the left ventricle. Okay, this is the left ventricle pressure graph, which is fluctuating a lot. Okay, so this is the pressure is increased during the contraction, then it relaxes, it moves below than 20. Okay, so, and this is the left ventricular, this is the left atrial pressure, which is below 20. So atria is a low pressure compartment and ventricle is the high pressure compartment, and the highest pressure is the aortic pressure. So this red line is for the aortic pressure, which is fluctuating between 80 to 120. Okay, so it has the highest pressure of all. So this is your aorta ka graph, this is for left ventricle pressure, and this is the atrial pressure. So after this, we move on to our Wigglers diagram, and we can see here that this is the volume graph and this is the pressure graph. So what happens is, it starts with the closure of the aortic valve, and this is the where your systole is starting. Okay, so further simplifying it, this is where the systole happens when the mitral valve is closed and the isovolumetric contraction takes place. Then the aortic valve opens and the ejection takes place. Because this is the ejection and the ventricle is contracting at a high pressure, the pressure is maximum here. And during the systole, the left ventricular volume would be less and the left ventricular pressure would be more, because the ventricle is ejecting out its blood into the aorta, so the volume would decrease during the systole and the pressure would increase during the systole. Then the aortic valve closes and then the mitral valve opens in the end. So this is your cardiac cycle simplified with the Wigglers diagram. So here we can see this is the systole and this is the diastole. Since the diastole is for more amount of time in the cardiac cycle, so this is the diastole and this is the systolic part of the cardiac cycle. Now the systole is from S1 to S2, and from S2 to S1 is the diastole. Okay, so if we see the hard sounds further, from S1 to S2 is the systole, from S2 to S1 is the diastole. So we can also remember it as S2, yani ki 2, which is for di, so it is for diastole. Also, S1 is due to the closure of the AV valves, and S2 is due to the closure of the semilunar valves. So S for second is for S2, and mitral valve closure, mitral tricuspid valve closure gives this S1. So A is for 1, that is S1, and 2 is for second, that is semilunar. This is the trick by which you can remember it. Now if we go further ahead in this, then from S1 to S2 is the systole, from S2 to S1 is the diastole, and S3, S4 comes here. So both the S3 and S4 both are diastolic. S3 and S4 both are diastolic since they are coming between S2 and S1. Okay, so now what happens is that now the S3 here is for the rapid filling, and the S4 is late atrial contraction. So the S3 is physiological. This is a very common question that comes in an exam, that S3 can be physiological in athletes, in children, and in pregnancy, but S4 is always pathological. S4 is always pathological. S4 is never physiological. Okay, so both these S3 and S4 are diastolic since they come between S2 to S1. Okay, now further moving on to the Wigglers diagram, we can see that A wave, pre-wave precedes the A wave, and A wave is for atrial contraction. Then P wave is preceding the A wave, because we know that the electrical activity comes first. Electrical activity is followed by the mechanical activity. So that's why it's P wave is followed by A wave, then C wave, then QRS is for the ventricular depolarization, which is followed by the C wave, that is for isovolumetric contraction. Then this is the V wave between the systole and the diastole. So the systole ends with V wave and the diastole starts with V wave. So somewhere between the systole and the diastole is the V wave. So it is corresponding to the second heart sound, that is the S2. Okay, so I think that's all with the Wigglers diagram. Now what we have to see is, here also we can see the same, that the atrial pressure is the least, this black line, that is that could almost come to 0, and this is your aorta ka pressure between 80 to 120 it is lying, the highest pressure. This is the left ventricular pressure, which is fluctuating a lot. Then this is the left ventricular and diastolic volume, and this is the left ventricular end systolic volume. End systolic volume is the volume that is left in the ventricle after systole. So the volume left in the ventricle after systole would all obviously will be decreased, because the ventricle has already ejected all of its blood into the aorta. Okay, so this is from your S1 to S2, this is the systole, then this is the diastole, this is the starting before S1 comes S4. Okay, so this is it, that is shown in this graph. Then okay, now here we have a bonus question for you, and the second heart sound corresponds to which point on the atrial curve? So just let me know in the comments what do you think about this question, and give me the answers there. Subscribe if you haven't already, to make such topics easier further with me, and don't forget to give a thumbs up, like this video. Thank you.